Hi there, I'm Carol from Microsoft's Application Insights Group. In this video, I'll demonstrate one way to accelerate root cause analysis of an application issue using time series analysis. Let's say I'm the on-call engineer today, and I just got a call from customer support. The support representative is telling me that over the past few days, there's been a growing trend in the number of complaint calls about application slowdowns. To complicate things up some more, not all users have been experiencing the slowdowns. It seems like the issue is limited to some segment of the users who use certain types of browsers or OS, and even then, the problem is not consistent. An intuitive way to start my investigation is to simply attempt to chart a breakdown of all the request durations segmented by the relevant attributes: operation name, server name, browser version, and OS type. The following query will produce a very large number of fragmented graphs. It's very hard to see anything meaningful in it. Why is the chart such a big mess? Let's count the number of distinct graphs in the chart. So, we have over 1,000 potential time series. Clearly, what we need is a way to keep only those visual parts that manifest a trend of performance degradation. Let's use time series analysis. First, we use make series to create a time series for each segment. For each segment, we create a series of the average request duration per hour in this time range. If there's an empty bin, the default value is 0. Next, we use line fit, which performs linear regression on the series to find the line that is its best approximation. We'll use the operator take to better understand the data structure in this phase. Each row contains the data of one segment. Let's focus on the first one. The second and third columns contain the time series data points and their corresponding timestamps. The fourth column contains the line fit output, which includes the approximated line and additional related details, such as the approximated line slope, the variance of the original series, and R-square, a standard measure of the fit approximation quality. We'll use the parameters slope and R-square to calculate a trend score, a measure that considers both the approximated performance degradation of the segment and its confidence level. We choose the top 3 segments by this measure. This gives us a much better result. There are 3 segments, all are manifesting a clear sign of performance degradation. The data account for requests coming from users of a specific browser and operation system hitting the same page. Now let's see if we can learn more about what's happening with the 3 servers. In this query, the operator join is used to examine the correlation of those servers' time series of request duration with time series of performance counters. We see a complete correlation between the servers that were manifesting a degradation in the processing time of request to those that manifest the symptoms of a memory leak. This gives up the root cause and completes our investigation. From this point on, an engineer who is familiar with the design of the system should be able to rationalize the impact on the specific segment of users we discovered above. We use time series analysis to detect increasing trends, but a similar analysis could be done in order to detect decreasing trends, filter trends with a slope threshold, and more. Series analysis can also be applied on a series of data points over a sequential variable different than time, for example, user age or number of requests. Enter this address to test drive our analytics tool and explore more of the language's powerful features. Thanks for watching.